welcome to Cambridge Chemistry channel with Ahmed. Be sure to like the video and subscribe the channel. Really helps the channel. This is question number 2 from 9701333 May June 10 paper. You are required to determine the molar enthalpy change of solution of ammonium chloride Fa1 when an experiment reaction takes place in a container in such as beaker some of the evolved heat energy is absorbed by the beaker. When an endothermic reaction takes place, some of the required heat energy is supplied by the beaker. The amount of heat energy evolved or supplied for 1 degree centigrade change in temperature is known as the heat capacity of the beaker. In preparation for your experiment to determine the molar enthalpy change of solution for Fa1, you will first need to determine the approximate heat capacity of 250 centimeter cube beaker. Before starting any practical work, read through the instructions in A and draw up a table to record your results. This is very lengthy question. Part A, determining the approximate heat capacity of the 250 centimeter cube beaker. How to determine the heat capacity of the 250 centimeter cube beaker? When sample of hot and cold water are mixed in the 250 centimeter cube beaker, some heat is lost to the beaker in raising its temperature. To determine the approximate heat capacity of your 250 centimeter cube beaker, you will determine the maximum temperature rise when a sample of hot water is added to cold water in the beaker. This is the method. Use a 50 centimeter cube measuring cylinder to transfer 50 centimeter cube of cold water into the 250 centimeter cube beaker. Okay, take 50 centimeter cube measuring cylinder to transfer 50 centimeter cube of cold water into 250 centimeter cube beaker. Use the 50 centimeter cube measuring cylinder to transfer 50 centimeter cube of cold water into 100 centimeter cube beaker. Note the temperature of the water in this 100 centimeter cube beaker and heat it carefully and gently until the temperature of the water in it has increased by 45 to 50 degrees centigrade. Then stop heating. For example, if the water is at 20 degrees centigrade, you should warm it to 65 to 70 degrees centigrade. Stir the cold water in the 250 centimeter cube beaker with the thermometer. Record the temperature of the cold water. This is the temperature at T is equal to 0 minute. Record the temperature of the cold water. T is equal to 0 minute. Record the temperature each minute for 3 minutes. After you have taken the reading at T is equal to 3 minutes, use the thermometer to stir the hot water in the 100 centimeter cube beaker. At T is equal to 4 minutes, measure the temperature of the hot water and record this value in the box below. Immediately add the hot water from the 100 centimeter cube beaker to the cold water in the 250 centimeter cube beaker. Stir with the thermometer but do not record the temperature. Continue to stir the water throughout the experiment. Record the temperature at T is equal to 5 minutes and then every half minute until T is equal to 8 minutes. Empty and rinse the 250 centimeter cube beaker. Dry it using a paper towel. Record all measurements of time and temperature obtained. The temperature T1 of the hot water at T is equal to 4 minutes is 56 degrees centigrade. This is a table. How to draw the table? Table per minute 0, 1, 2, 3, 5. 0 minute, 1 minute, 2 minute, 3 minute, 5 minute and 5.5. Temperature degree centigrade at 0 degree centigrade 24.5 and 24.5 at 1 minute, 24.5 at 2 minute, 24.5 at 3 minutes, 38.0 at 5 minutes, and 37.0 at 5.5 minutes. And after 6 months it after 6 minutes it is 36.5, and after 6.5 it is 36. At after 7, 35.5, 7.5, 35, and 8 till 8 you have to measure the temperature. This is 34.5 degrees centigrade. Graph plotting. Plot a graph of the temperature of the water in the 250 centimeter cube beaker, y-axis against time, x-axis on the grid below. Do not plot the temperature T1, the hot water at T is equal to 4 minutes. Through the points from T is equal to 5 minutes to T is equal to 8 minutes. Extrapolate both sides to T is equal to 4 minutes. From the extrapolated lines, read the minimum and maximum temperature at T is equal to 4 minutes. Record these values in the spaces provided below. Determine the values for the two temperatures in at T is equal to 4 minutes. Now plot the graph. So these are the after 1 minute, 2 minutes, 3 minutes, same, and after 4 minutes, 5 minutes, and 6 minutes it is at 6 minutes it is 36.5, at 6 minutes it is 36.5, at 6.5 it is like 36.0, and at 7 minutes it is about 35.5, and at 10 minutes it is 34.5. Now in this way extrapolate the graph, okay, till 5. These are the 2 points, 4 and 5 extrapolates. Now this is 38.5. So time T2 at T is equal to 4 minutes. At 4 minutes it is 24.5. This is initial temperature. Maximum temperature T3 at T is equal to 4 minutes is 38.5. So this is the maximum temperature, 38.5, and T3 minus T2 is equal to 14 degrees centigrade. 38.5 minus 24.5 is equal to this is 38.5 minus 24.5 is equal to 14. And temperature fall for 50 degrees centigrade of hot water from 100 centimeter cube beaker is equal to T1 minus T3. This is T3 and T1 is this is T1. Do not plot the temperature T1 of hot water at T is equal to 4 minutes, and this is 24. So this is equal to 17.5 T1 minus T3. This is T1. So T1 is equal to 56.0 minus T3, 56.0 minus 38.5. So this is equal to 17.5. Now calculations working should be shown in all calculations. 4.2 joules are absorbed or released when the temperature of 1 centimeter cube of water changes by 1 degree. Calculate the heat energy gained by the 50 centimeter cube of cold water in the 250 centimeter cube beaker. Q is equal to mc delta T. M is the total volume of the liquid, that is the equal to 50 into 4.2 and change in heat this is equal to 14, and now the heat energy gained by the cold water is 2940 joules. Calculate the heat energy lost by 50 centimeter cube of hot water from the 100 centimeter cube beaker. So this is 50 centimeter cube is volume of water into 4.2 heat capacity and into 17.5. This is 17.5. 50 centimeter cube of hot water from 100 centimeter cube beaker is 17.5. This is 56 point T1 minus T3, 56.0 minus 38.5. So the answer is 3675 joule. The difference between the values calculated 1 and 2 is an approximate value for the total heat energy absorbed by the 250 centimeter cube beaker during the experiment. The heat capacity of the beaker is the amount of heat energy absorbed for 1 degree centigrade change in temperature. So approximate heat capacity of the 250 centimeter cube beaker is heat energy lost minus heat energy gained. So divided by T3 minus T2. Use your answer to 1 and 2. Use your answer 1 and 2. This is heat gained and this is heat lost. Calculate the approximate heat capacity of the 250 centimeter cube beaker. So this is heat change T3 minus T2. So heat lost and heat gained is equal to 3675 2940 divided by 14. This is the T3 minus T2. So the answer is 52.2. The approximate heat capacity of 250 centimeter cube beaker is 52.2 joules centigrade inverse 1. Now determine the change of solution for ammonium chloride. Follow the instructions below to find the temperature change when unknown mass of solid ammonium chloride dissolved in water. You are provided with 2 samples of ammonium chloride. You should use the sample labeled NH4Cl in experiment 1 and the sample labeled Fa1 in experiment 2. Experiment 1. Enter all the result in the table below. Weigh the stopper tube containing minimum ammonium chloride, which is labeled NH4Cl. Use the 50 centimeter cube measuring cylinder to transfer 100 centimeter cube of cold water into the rinsed and dry 250 centimeter cube of beaker used in A. Okay. Stir the water in the beaker with the thermometer and record the temperature. Add the solid from the weighed tube to the water. Stir the mixture constantly with the thermometer. Record the minimum temperature obtained in the solution. Reweigh the tube labeled NH4Cl, its stopper, and any residual ammonium chloride. Empty and rinse the beaker and dry it using a paper towel. Experiment 2. Enter all results in the table below. Weigh a clean dry boiling tube. Weigh between 9.8 gram and 10.2 gram of Fa1 ammonium chloride into the boiling tube. Repeat the procedure in experiment 1 and record the minimum temperature obtained when this mass of Fa1 dissolved in 100 centimeter cube of water. Reweigh the boiling tube and any residual ammonium chloride. Mass of tube plus ammonium chloride is record the table like this, 44.90, and write down the reading over here, 44.90. This is mass of tube plus ammonium chloride is these are the supposed reading. You should use your own reading in the experiment. 44.90, 38.39.80. Mass of empty tube per gram is equal to 29.70. Mass of tube plus residual ammonium chloride is 29.70, and this is 29.70. Mass of ammonium chloride per gram is equal to 15.20 and 10.05. Initial temperature of water 25.5 and 26.0. This is for experiment 2, and minimum temperature obtained 16 and 20 for experiment 2 and 16 for experiment 1. Temperature fall is equal to 9.5, like 25 minus 25.5 minus 16 is equal to 9.5, and in this case 26.0 minus 20.0 is equal to 6. This is the temperature change delta T. Now calculations working should be shown in all calculations. Number 1, use the temperature fall from D experiment 1 to calculate the change in heat energy of the solution. 4.3 joules are absorbed or released when the temperature of 1 centimeter cube of solution changes by 1 degree centigrade. So MC delta T. So this is 100 centimeter cube of water. 100 centimeter volume of 100 centimeter cube equal to mass. So so Q is equal to MC. 100 is the volume of water. Volume of water is equal to mass. Please keep it in mind. Volume of water is equal to mass, or centimeter cube. 100 centimeter cube is equal to 100 gram. So this is equal to the change in heat energy of the solution is 4085 joules. To calculate the total change in heat energy as ammonium chloride dissolves in water, the change in heat energy of the 250 centimeter cube beaker has to be added to the change in heat energy of the solution. Explain why these two changes in heat energy have to be added together. During experiment, beaker also absorb or lose heat energy, so we'll add this to calculate total heat energy. Use your answer in 1 above and the approximate heat capacity of the 250 centimeter cube beaker calculated in C3 to calculate the combined change in heat energy of the beaker and solution. This is 4085 we have calculated above, plus in C1 in part 1 plus 52.2 into 9.5. So this is part 1. From part 1 is equal to this heat and plus 52.9.5 is the change in heat, and 52.C3. So this is the approximate heat capacity of 250 centimeter cube we are using in this, we add these two values, 52.2 into 9.5. So this is equal to 4581 joule combined change in heat energy of the beaker and solution. Calculate how many moles of Fa1NH4Cl were used in D experiment 1. So mass which are using is 15.20 divided by 53.5. This is mR of ammonium chloride, and the mole is 0.284 mole of Fa1 was used in the experiment. Calculate the enthalpy change when 1 mole of Fa1 dissolves in an excess of water. This is the molar enthalpy change of solution, delta H solution NH4Cl. Make certain that your answer is given in kilojoule per mole, so, and has the appropriate sign. So 0.284 mole releases this energy, and so what would be the energy if for 1 mole? So this is equal. So you can write down this formula. You can calculate by using this formula, Q divided by heat gained by the ammonium chloride, Q divided by N. So this is N 4581 divided by 1000 converted into kilojoule divided by 0.284. So this is equal to 16.13. And because heat is gained by dissolving ammonium chloride, so that's why sign is positive. Explain the significance of the sign you have given in part 5 and how it is related to your experimental result. The reaction is endothermic, or temperature falls during the reaction, because dissolving of salt is endothermic reaction. Evaluation. A data book value for the molar enthalpy change of solution delta H is 15.2. The values you have gained may be significantly different from this value. Calculate the difference between your value of delta H solution and the data booklet value. Record this difference below. Express this difference as percentage of the data book value. 16.13. We have 16.13 in the experiment, and the data booklet has 15.2. So the difference is 0.930, and 0.930 divided by 15.2. This is the theoretical value, and the difference is this into 100 is equal to percentage difference is 6.12%. Source of error. Describe one major source of error in this experiment. Suggest an improvement which would significantly increase the accuracy of the experiment. Explain why your suggestion would produce a more accurate value. Description of the major source error, heat gained from the surrounding. So this is the major error. Suggestion improvement, you can use plastic beaker or lagging for insulation. Explanation why suggestion would increase experimental accuracy. Less heat gained from the surrounding will lead to accurate results. So this is all about of this question. This is very lengthy questions carrying 25 marks, and so please if this type of question came, please do it very carefully. Okay, hopefully you understand. If you understand, please like the video and subscribe the channel.